can hear you fine. Can you hear me?
Yeah, I can hear you now. I was just asking if you can make sure to record this.
It's recording right now, so fantastic.
Okay, great.
Yep.
Thanks, Eric. I'm going mute.
All right. Well, let's wait a minute or two, then we can get started. All right, so it's 6:01. Let's get the presentation started. So my name's Eric Hillard. I'm actually a TA for your class. My background is really my work for Oracle in two capacities, one on the life sciences side and one on the healthcare side. And it's probably what you'll see in the presentation is a hybrid. So the life sciences is quite interesting from that perspective. So we'll look at, what in terms of study data, and we'll look at some of the omics stuff that I typically do in the healthcare side of the business. So this is going to be our agenda for today. So a little history on R. Some of the, I think, sites that are quite useful when you're dabbling with R, when you get proficient with it, there's some, a few good ones out there. The ones that I think is really, really great is the Blogger site, the R bloggers. A lot of good information, a lot of sharing of code, a lot of, what's going on within the industry. So it is quite interesting. The next topic is going to be basic R UI. We'll take a look at that. Then we'll go into the installation of RStudio, installing of packages, how packages get updated. And the reason I want to go into that because there are thousands of packages out there for R. And one of the things is to make sure that, you keep your packages in sync with what's actually coming out. And mainly, sometimes there are bug fixes. You want to be able to capture those. You could, if there's functionality that you really don't care about, you could just leave it on the same version. But it's usually best to update. How to get, getting help with packages, and that's important. Many packages have many functions. And understanding those functions is vital in terms of using and getting the most out of these packages. And then the other component is, if you're not finding the appropriate help, you can get that feedback back to the person who actually developed it. And the next release of that package, you could probably see that included. So it keeps, I think, the developers that build these packages, and we have to remember, it's open source. So it's basically the folks that actually are putting these packages together. They do get rigorously tested. But that said, it's still open source code. Then we'll go look at that data and how do you use data within R? How do you access data within R? We'll look at code and then graphs. Right? So a little history on R. So you'll notice that R has grown from what it used to be, which was really the R console. And R is really based on S. So S was developed in the late around 1976. That's when R went in AT&T. So it's been around quite a while. 20 years later, it kind of morphed into R and an open source R. And when it was initially released, it was really just binaries. So there was nothing else besides the binaries. So it then developed into this package called NTP to R. And I'll walk through each one of those to give you a flavor of what the R console is, what NTP to R is, and what R Studio is, because I think it's quite interesting from the evolution of this product, how it's gotten to where it's come from, which is quite remarkable. NTP to R itself is basically Notepad to R. So they built this, this integration between the two, so where you can actually type into Notepad and actually hit a command line, and it'll actually send the code to your R console, and that'll execute there. And I'll show you how that actually functions. Then we'll go into R, which was developed, like I say, in 2011, R Studio, which is a nice integrated development environment with all the attributes that you require from a development environment. And what I mean by all the attributes is basically you can see your data, you can see your code, you can see a log, and you can see all the packages you actually use within your code. And I think that it is kind of a nice way of working, and it's very conducive from that perspective. All right, so our console. It's pretty rudimentary, has basic features. I'm going to log in right here and start her up. So here's R. What you're seeing is basically the GUI. Very rudimentary from a development perspective. Everything you can type here. Now I'm going to type a little piece of code. So I'm going to say X here. And I'll say 2 plus 3, all right? Now, that kind of initializes this little X variable. If I type X, you'll see it says 5. Now, you'll notice what happened here. I tapped an uppercase X, and it doesn't find that object. And that's because R is extremely, and I do mean extremely, case sensitive. If you misspell, if you don't use the same syntax, it will really give you an error. So you have to be very careful on that. And I think when you're learning R, that's typically the errors you'll fall into, is why isn't this running? Why am I getting an error? Look at the syntax, look at the case sensitivity, because that's key for the application to work. So it's just, R as a whole, and you can see this is pretty straightforward. Question is, copy and pasting, not really the best functionality out of this. That said, at the top you have this menu bar. I mean, you can save your code, right? You'll see the concept of workspaces. Once we get to R Studio, they've actually developed that into a much more robust approach to workspaces. And it's nicely, tightly integrated. So your code and your data and your packages, when you load a workspace or what they call a project now, it actually loads everything for you. You don't have to worry about it. It'll load the particular packages you require for your code. So that's very, very nice from a usability perspective. Same functions here, copy, paste, clear console, and if I do clear console, I'll just clear everything out here. Annotations, computations, buffeting, all the stuff that you'll find in this particular release. And it works. Let's say updating packages, installing packages. When you do an install here, it'll actually log into the CRAN site, which we'll take a look after, and we'll show you how that works and where you can find packages, how you can install them, and updating them. But it's very different than what you'll see in R. Say if I clicked on here, install a package, what it's trying to do is find the closest mirror to be able for me to install a package. It'll bring up a list of countries. So what you typically want to do is pick the one that's closest to you, because some packages are quite large, and you don't want to be sitting there waiting a while. So I'll pick Texas here. And once I pick Texas, it'll bring up all the available packages that are out there. And typically they all have the same ones because they do get replicated across the board to all the sites. but it's a different way of doing it. All right, so I cancel that out. And this is basically how you set up your windows and your tile horizontally, vertically. And then you have your help and your manuals. So for our console, that's going to be it. And now I'm going to show you what doing the same command in NTP to R. So let me cancel out of this. So I'll exit. Do you want to save the image? No. Actually, I just said yes, didn't I? But that doesn't matter. All right, so you'll notice at the bottom here, I have an NTP to R executable. If I click on it, I can say start Notepad++. So this is a second, from the evolution perspective of R, this is pretty much, the intermediate one, where now you're using Notepad, which is a little more richer in terms of functionality than a straight console. And you can do exactly the same thing. So if I, type, and we'll use an uppercase here. And we'll do 2+3. So what I can do now is basically control, and it is F8, right? And what happened? When I hit Control F8, this command basically started the R console and actually executed it. And you'll see it right here. But that was the first command. That means my object was initialized with 2+3, and that should equal to 5. So now if I type in the X here, right, and I hit Control F8, it'll go out and execute that particular thing, and I'll see my 5 here. So from an evolution perspective, you're not limited now just to typing into this this very simple UI. You have a little more control here, and if you do a lot of coding, and Notepad is quite nice for that because you can do indentations, easy commenting, so it makes it very easy to do comments, code, indentations. So from a usability, it's a lot easier to use. That said, it's not, it's not the best from a coding perspective. The next piece would be RStudio. So let's navigate there. I'm going to shut this down. Close the window. No.
Hey, Eric.
Yes.
Can you pause here for a second? Give
Sure.
a chance to these guys. Maybe they have questions.
Sure.
Anyone, any questions on the line? You guys had a chance to play with this since last week. Okay.
Okay.
I think we're good.
Problem. All right. So we went through NTP to R. Now, RStudio. It's kind of, like I said, the next best thing. It's your Notepad. It's everything combined into one, where you can write your code, save your code, package it into a nice, neat set of commands. It's an all-in-one environment. Makes like I say, development much easier, and it also lets you manage your projects from a structural perspective, from a folder perspective. It just makes that aspect a lot easier. So when you're creating multiple projects, you just create a project and it'll actually go out and just create this little folder structure and save everything to that folder structure. So we're talking about sites. So creating sites. So the RStudio site, if you want to find anything about RStudio, this is a great site to find it. A lot of information. You can definitely work out, take a look at that. Our project, Definitely, that's a great, a lot of good code out there for that from this site. The bloggers, which is my favorite, a lot of folks commenting on packages, building packages, demoing particular code that they've developed or packages. So it's really, really nice from that perspective. This is a stats. So for the folks that like stats, this is the site to go to. And it'll actually show you a lot of ways using R to run stats. And the R cookbook, which is really for graphing. If you like to graph and take your data into that next level, this is where you probably want to go to. So if I went to, let's see here, let's pull it up. Oops. I can pull it. All right. So here's R, basically the CRAN site, and this is just looking at RStudio, where you can find, typically installs on these three environments, Linux, OS, and Mac or Windows. And you'll get the installation information, your files, your zips, everything you need to get this started and running. Let's put it in our home page here. So our home page, this is a statistical computing environment. Let's go right to now I'll give you a little more. So here we go. These are all your CRAN mirrors. If you want to find that, you need to get to access to them. You can get to this. This is quite interesting. So each country has a few mirrors. You can actually, and there's quite a few of them out there. You can navigate through that and go and select a country you need to pull your packages from. Here's your stats in terms of all your sites and all that. It's quite, how many packages are out there, regions. So a lot of information about CRAN itself. And just a little information about that. So packages. So if we take a look here, there are a lot of packages. Here the available. So as you can tab through them. There's quite a few of them out there, and they're growing by the day. As folks develop packages, they're getting posted. So there's pretty much a package for everything or anything. I don't think I've used all of them yet. We typically, I stay, within the stats and the omics area, but I'm saying the graphing. But they're, like I said, I think there are over 1,000, maybe 2,000 now, different packages that you can use. So you can search for them here. Great site for that. And then you get into your documentation here, and I think that's a great for anything you need to do. So if you want to do a little search and say, okay, I want to look for let's call ggplot, which is a great graphing tool. So ggplot2, here it is. If I click on here, it'll take me to the particular package, which version it's on, and then basically here is some documentation where I can download it from. Here are the zips. So if you're using Windows, you can have that. If you're using Mac or Leopard or binaries, Maverick, so everything is here. So you can just click and download, and you'll notice all the different packages where you have dependencies on. And that's also quite interesting. So when you do install a package, sometimes it'll actually pull more than one down because it needs them to be able to do the work. One thing, if you've used our console, the dependencies sometimes did come down. So you ended up having to install many of them manually. Now with RStudio, it's done for you. So it's quite nice from that perspective. All right. Let's go back to our presentation. So let's go into the installing of R, which we looked at here. So, the download R for Linux or download R for Windows. So it's a zip file. Really easy to install. Just pick the place you want to install it to. Typically, it will be on your C drive, or if you have an auxiliary D drive, just put it on your D drive. It doesn't care, and you just install it there. And like I say, it's a minute install at home. at most. So it's fairly straightforward from that perspective. Tool options, and this is for editing. To make code nice and readable for the folks that have to learn, it's good to tab in so you know exactly where a piece of code starts, where a function starts, it ends, and then all your parentheses. You'll notice that parentheses are always required. And that's another thing, if you don't have the matching one, it's going to fail. It's just give you an error. So that's something also to be, there's a lot of parentheses everywhere in R, so that's something to be cognizant of also. So let me bring R up while we're here. I can show you exactly what we're talking about. Is our studio? Okay, so let me clear all this out. And I'll clear my console, clear my observations. So R in itself, I say, is very nice from a usability perspective. Right? So you have these 4 quadrants, as I would call them. You have the first on the top left here. This is where you code. This is where you basically, all your command lines. I'm going to start with this one here, your typical one. Make that easy. And we'll say 3 plus 4. And then if I type in this, you'll notice nothing runs. But right here, you have your run command or your source command, so run the source. And what happens when you do run source, it actually runs everything that's here. If you do run and you say a command line, it'll actually just run that that command. So it's very nice from that perspective. So it gives you that choice of running just a little piece of code, a little snippet, or all of the source. So as you're coding, you can easily see the output being generated below. Makes it extremely nice. What you see on the right-hand top here is those objects you're generating, and what their values are. So if you're creating data sets, you'll see those data sets being loaded here. Any subsets of data, you'll see them loaded here. So this is where your data typically will show up. All right, but quite nicely. If I wanted to import a data set, I can do that, and I can go and pick out. Let's go to my R working, and a couple. Where's my little? So here's a data set. This load fairly easy to do. And you can see it has 46 observations, 38 variables. For the folks that are in stats, so basically 46 observations means there are 46 records in this data set. And there are 38 variables. That means there are 38 different columns in here of data. So now you see it here, but at the same time, when you want to open it, you can see it in this little quadrant. So it makes it nice to be able to visualize your data as you're coding with it, and that's what typically happens. Then you have your last quadrant right here. And this is where all your packages reside, the packages that you use. I opened a particular area, and it shows me all the objects that are in that particular project. Then if you're graphing, you'll have all your graphs, the packages that you can use, and to use it, is all you have to do is really just click on them. So if I want to just say I want to use this package, what it'll do is actually go out and load that package up for you. To do it in R, you basically type in library and type in your library you want it to load. So very nice from that perspective. And you'll see sometimes you get these warning messages because RStudio, the package is built before RStudio. It's not an issue. Works just as well. So this is R as a quick overview of R. Now, I'm going to show you something that I think everybody should, as you're going through the course, quite useful. So, new project. So if you, I don't want to save this. Right? So I want to create a new directory. I'm going to create an empty one, and I'm going to call it. And this is going to be R class. Right? So now it goes out and just creates this folder, and everything I need everything I create from now on will be stored in this R class folder. So if I load data, I create code, it's all going to be in this folder. So it's nicely classified, compartmentalized, very nice to use, easy to use. Now you don't have to wonder where your code is being saved to. It's always going to be saved to the same spot. So if you have multiple projects open, it keeps track of that and lets you do that. So it's very, very nice from that perspective. And we'll go into a little more code after. Go back to the presentation. So advantages, I say running of code. I think, from being able to type a piece of code, execute it right at the same time, run multiple pieces of code and see the output at the end. Also very nice. Storing code in datasets. I say, when you're using projects within RStudio, very, very nice to do and very easy to do. And then installing packages and updating existing ones. So one thing I think about is when you need to install a package, right? Here you have all your lists. There's a little button here, install. And all you have to do is put the name of the package you're looking for. And then it'll go and it'll actually bring in all your dependencies for that package, which is, very nice, and you don't have to worry about everything else. And then the update, right here it tells me I have these 4 packages that are out of date. There are new versions available. Do I want to install them? So that's the nice aspect. The RStudio doesn't have that. So you can keep your packages up to date, and that makes it very, very nice. Keyboard shortcuts, and there's quite a few of them. If you look at the help, there are a ton of them. Debugging, there's a debug function to be able to debug your code. So, right here, and this is, if you want, breakpoints, toggle breakpoints, execute a line, step into a function. So, stop debugging and on error. So it gives you a lot of functionality to be able to debug what's going on with your code. And that's nice from a development perspective. And then source on save. That is this little button. So if I have, like, a new file, our code, source on save, right? As I code, I can actually have this being saved at the same time, which is, say, who hasn't lost code. So once you execute, it actually executes and saves a copy. And that's very nice. Who hasn't lost code? I mean, a lot of people do. I know I have. This I use all the time, so it makes it very nice for me to use. Workspaces and directories, we talked about that. That's basically, the ability to, create these folder structures and these directories to be able to use your code and save your code in the folders and the formats. That's always very, very nice to manage around that. So I would think, starting up, put this into your normal development routine. That when you start a new project, you create a workspace and a directory for it. You'll see that managing the different pieces of code makes it really, really very nice to go from an R perspective. We did that, searching for our packages. So that in itself is, just type in whatever package you're looking for, and it'll bring up all the packages that are available for within that name or close to it. And that's, like I said, there are thousands of packages, so tabbing through each one of them makes it very hard. And then installing, we just touch base on that, is how to install the little install button. easy way to do it. Just select the package you're looking for, type in the name or a partial name if you know it, and then it'll bring up all the packages that you're looking for or that have that similar name. Updating packages in RStudio. As I showed you, I had 4 of them that were outdated. So I could just went out there and just say, okay, update all these 4 packages. R makes that very, very nice to do. So I think that's a nice little feature that we have now today. Very good. The help. We always like help. Help is good. So help, this little button right here. Everything you need to know about RStudio within here. And then once you load a package, you can actually get help on the package by typing in the package name. So if I went and I said, I think it's AP. It's not APA, I think it's AD, sorry. If I spelled this correctly, it would be better. So I'll have to figure out why that's not coming up. All right, so next is the case sensitive, as I was saying. So yes, R is extremely case sensitive. You have to be very cognizant of what you're typing, how you're typing it. Otherwise, it becomes you end up having to try to figure out how to debug it. And that makes it very hard to do. So just make sure what you're typing, and then I think you should be good from that perspective. Data, reading, displaying, selecting, adding variables. So let's go and do that. So yes, that's, I think the first thing you need to know is how to load data. And R provides you multiple mechanisms to do that. So let's load this up. It's R over here. Clear all this out. We can show you exactly how that works. All right. So this is a basic, fairly straightforward little piece of code. First thing is reading a data set here. So we have a data set, and it's a CSV file. I'm going to load that into my console here. I'm going to select a set of variables from it. I'm going to filter those variables, rename a couple of them, and then add another one and display it. So we can see that, let me execute this and I will show you what that looks like. So you'll see on the left what happened. We have our data set that was read. So what we see here So we loaded our library. We loaded this particular data set, onc, all right? We selected X variables and called it a cohort, which is this one. Let's take a look at that. And it basically has a subset of the variables in it. Same number of observations, but a subset of the variables. Then we basically said, all right, let's filter out all the males that are greater than 30. And we take a look at this one. Here's all our males that are greater than 30 that were in this data set. Okay, so it's fairly easy to do from that perspective. And we renamed a couple columns in that data set. And this is where you actually can see which, so I said in AE cohort, male, I want to rename the third column and the fourth column. So I made those uppercase right here. So they matched everything else. Okay. Last thing here is adding a column. So how to add a column, and then that's typically, when you're doing a lot of manipulation of data, you're going to be adding a lot of columns to be able to track what you're doing to some of your data. Here's one. Basically, I've added to the cohort a column called 1, and I put a column called count, and I put 1 in it. So if I went and looked at it, here's that column, and it's called 1. All right. And then at the last command here, I basically said, type out everything that's in the data set I was reading. And here it is right here. So all your data sets. Columns and observations in basically the console. So that you're actually reading in. So as you can see, it makes it very nice to work with, easy to manipulate. Any questions on this? So R has multiple ways of reading in data. It reads in text files. It'll read in a relational database if you install the RODBC. So that's quite easy to do. It actually will also read in websites. So if you need to bring in a website and read that, it actually lets you do that too. So yeah, so the ability to to use RODBC, the ability to reach from an internet site, so you're able to do that with R also. So that's something I'll show you in a little while. So here's a subsetting, and I actually showed you this, how you subset data. A couple of the variables, very easy approach to creating these. And then you get into graphs. Graphs, you have a lot of graphs in R. So you have tiles, you have linear, box plots, all sorts of different particular graphs. And I'll show you how those work. I think they're very, very interesting from that perspective. So you're able to basically create, and I say the number of graphs available are quite astonishing. They let you create all sorts. And also, they let you basically, let's say, generate all sorts of colors, and I'll show you how easily that's done. So you basically have here is a simple graph that I drew up for a study, a diabetes study, looking at diastolic. And So we'll take a look at that. Here's another graph, density graph. So we'll look at that, how that actually functions. And then we'll get into stats. That's something I typically do. We'll look at how do you do stats in our one-way ANOVA, two-way ANOVA, how that runs. And we'll go into OMIC. So let's first look at the stats perspective. So let me load up a new package. So what do we have here? So I'm going to walk you through the code before I execute it. Let me clear out the rest here. So we have, far away is a stats package. I typically use quite often. We'll redo. Next thing is to read in this data set. We'll do that first. We'll display the data that we've just read in. And to display data, all you do is type in the object you want to display. We'll run a summary on the data set. And a summary basically looks at every column, gives you the mins and the maxes of the data and the means. So you have a good indication of what's in your data once you read it. Then we'll sort the data based on the AE term. You'll notice here we use cbind. So in order to graph, you need to be able to have numbers in R. So graphing without numbers is pretty hard to do. So what we do is do this what we call cbind, and that creates a table of numbers based on your data. And then we'll graph a couple packages, and you'll see here I'm graphing a histology, I'm plotting a density, and I'm plotting another density, but using a different approach than a box plot. Once I have that, I'll actually run a one-way ANOVA using and say for the folks that are not stats, right? So ANOVA, basically, you're looking at your dependent and independent variables and looking at really the deviation from that perspective. And then the two-way ANOVA, you're looking at two independent variables. So let me, and then at the end, I run a summary on the oncology data set. So let me execute this code. So what you see, two things, your data. So here's my variables. Here's all my values that I've kept track. I've generated these plots, and then I have all the summaries here. So let's take a look at the plots. So my graph that I generated, I saw a pressure graph. That's an easy bar, it's a bar graph. What you, from a graphing perspective, is this is the code behind it. So it's this little piece of code here where you tell, what's the y-axis, what's the x-axis, to give some names to it. Now you want a title to your graph. Here's your main title. You want your column, and this is the column you're graphing. And I use Rainbow, and Rainbow lets you basically color code each one individually, so or make it a different color. And you can specify which colors if you wanted to, so it really gets granular in terms of what you need to do. Here's a density. What you'll see here is basically the bell curve, and where your apex is on that. Here's another density, but using, like I say, the little sign, and this sign is can be, you can put anything you want in there, so that's quite nice. And a box plot. Same thing here. The box plots, you can use different colors. I use gold, but if you want to use a different color for each one of them, you could do that. I think it's, like I say, it's very flexible from that perspective. What we have at the bottom here is what we've executed. So let's navigate to the top. So the first thing we did was read in the data set here. Then I said display what we just read in, and this is the data that was just in the data set. We're going to deal with AE, which is this. Okay. Now what we did was run a summary, and I was saying here, summary, this is the name of the study. There's only one variable by that. There are 46 observations with AE. User subject ID. What's the minimum number? What's the max number? What's the median number? First quantile, third quantile. So it gives you that for every one of those values that are in there. So if you're looking, for information on your data, writing a summary on it gives you really good information. So something definitely to leverage when you're playing around with data. Okay, and then I think that's it for that. All right. And then we run our Anovas. Our Anovas are packages also. They're from the faraway one. Very typical stats package to use. So that's a little more complex from a package perspective, code perspective, graphing perspective, but you'll see the graphing is and the plotting is fairly easy to do once you've structured your data in a fashion that can be easily used. And you'll typically have to use these for fashioning that data to something that's usable. All right. Then some good here, and then basically here is your different values and variables, like I was saying before. So that's some of the stats. Next thing is omics. Omics packages. So let me clear all this out. So there are, in omics, there are quite a few packages. I say there's the bioconductor one, 8. There's so many of them out there, and I'll go through a few of them. So any folks that are aware of the NCBI site, which is the National Cancer Bioinformatics Information, that is there's a lot of information, a lot of data you can actually get from there. GeneBank is your sequencing data bank. And then your sequence comparison will go into coding in terms of what we do here. Take a look at that. So here's some of the packages I use within the omics area. Sequence 2R, sequence NR, 8, Biobase, allele match, BioString. I said bioconductor is the other one, so there's quite a few of them that lets you manipulate DNA sequences. So this is a site for NCBI, for Biotechnology Information. So if you have a chance, just go out there and take a look at it. It's quite interesting. A lot of information, a lot of good information. GeneBank. So GeneBank is one of the data banks. There are at least maybe, I don't know, 60, 70, maybe more out there. So it's part of the National Healthcare site. So it's National Institute of Health, so it's part of that. So you get all this data that's inputted into this data bank, which you can retrieve and use for research. So it's quite good for that. So let's take a look at retrieving sequence data using R. All right. So let's go back to our R and pull this up. So open this up. So here we go. So we have, let's go through the code before I execute it. So we're loading two different libraries, iterator and sequence in R. We're going to choose the data bank we want to pull from, and that's basically we're going to GeneBank. And this is making a connection out to the web and pulling it from there. Then we're going to create a file called cancer, and that'll have X number of sequences. So it's going to create a FASTA file. And FASTA is typically used for sequencing. It's a good way of storing your data. And from there, we're going to take that and do a comparison of a couple of strings. And you can compare all the strings, a couple of them, depending on what you're trying to achieve. So here's, sequence 1 is going to get compared to sequence 2. Right? And here we create this, and we create a global alignment and compare those two sequences. And then you'll get the information that you're hoping to get to. All right, so let me execute this. So it'll take a minute, to do that. I said this is also dependent on my connection, and looks like, yeah, and sometimes, they're running stuff behind the scenes, and they don't let you connect, but not sure why that's happening today, but it is. Let's see if we can try again. Yeah, so it basically says cannot open the connection. So there's something going on with the site. They could be just doing something on it, so which is not letting me get to the site. Let me try another piece of code I have here. I think this one may have run into the same issue because I am getting it from the same site. Well, that one ran, which is good. All right, so what you saw, so my FASTA file was generated. So, and that, like I say, contains all these sequences within the data. So, a whole bunch of sequences in here. Here's the session number. So this is basically the number attribute within the database. So if you need to go look and find it, just put that number in there and search for it. You'll be able to pull it down, get the same sequence. We load the biostring. It's fine. Then, yeah, basically you're doing this pairwise alignment between the two strings that you've selected, 1 and 2. And since these objects, so typically what you're looking at, it's either a data frame or a matrix. So for the folks that don't know what the difference is, data frame has mixed classes. And what I mean by mixed class, it's either can be number or character. A matrix can only be numbers or only characters. So you create these objects when you're pulling data in. So anytime you load a data into R, you're creating, typically it's a data frame. And then the reason for that, because you have these mixed characters in your data that you need to be taken care of. Then we're comparing these two. So we've, you'll notice how I actually access the two from the FASTA file. So it's reading the FASTA file that was generated, and this is the one here, and then basically saying, okay, take sequence number 1, take sequence number 2, load the biostrings database, and then align, run a pairwise alignment against the 2, and then get basically the difference out. So it's very, very, very interesting stuff to deal with. And then basically what I'm outputting here is basically the GC concentration of the particular set of data that I was looking at. So you're comparing GCs of the different strings. So it's very, very rich in terms of functionality. Nicely, I say, very easy to use once you've understood all your packages. So I think quite interesting from that perspective. So, FASTA file, what I was saying is basically just, a typical file that we use in sequence for sequence data. You'll see that quite often if anybody here is in bioinformatics program. Aligning the sequence, so, bioconductor has a set of sub-packages, biostring is one of them. All right, very good. I think that's it. So do we have any questions? We'll wrap up the session. Okay, very good. Well, thank you very much, everyone. If you have any questions, feel free to shoot me an email. If you want a little more details on any of this, I'll be happy to answer. Thank you, and have a good night.